Now, design patterns in any programming language are the solution to common problems in software design. These are blueprints which can be customized to suit the need, unlike a library or a code file which can be simply pasted into your program. In this course, we are going to cover some major design patterns that are widely used in PHP. Some of the major topics that we will cover include the importance of design pattern and how it varies from design principles, the creational design patterns, the structural design patterns, and the behavioral design patterns. By the end of this course, you will know if you should add a design pattern to your application, and if yes, when and how. Before beginning the course, you should be familiar with writing codes in PHP, and you should be aware of the design principles and the OOPS concept. Now, speaking of the decorator pattern, it is defined to allow us to add new behavior to existing objects by placing these objects inside special wrapper object that can contain the behaviors. Let us see what this means. Taking a real-world scenario, now let's say you bought a gift for someone which you need to wrap. So you put the gift inside a box and wrap it with a beautiful wrapping paper. Now after the box is wrapped, you add a ribbon to it and decorate it, and then you put it in a gift bag and gift it to the person. So this way, you have decorated a small gift with numerous layers around it, without actually making any changes to the gift. Or you can say, you have used a decorator design pattern. Now coming to a software example scenario, let's say you have started a pizza shop, and for that you create a pizza class. In it, you have two functions, getDescription, which describes the pizza, and then the cost, which returns the cost of the pizza. Now you are serving pizzas of three types: Margherita pizza, Veggie Paradise, and the Farmhouse pizza. Each comes with a cost. So our base class is pizza. We have subclasses Margherita, Veggie Paradise, and Farmhouse, which extends the pizza class. So far so good. Now let's say you want to add variants to it and add additional toppings into the pizza. Now each variant or the toppings has their own price. Let's say extra cheese cost 40 rupees, jalapeno 20, and olives cost 20 bucks. So one of the way is using inheritance again. We create additional subclasses, let's say Margherita with extra cheese, Margherita jalapeno, and Margherita olives. Now you might also add these variations to the Veggie Paradise as well as the Farmhouse pizza. Now this is going to create a lot of subclasses and a lot of code repetition. So this doesn't seem to be a good option. Else, what we can do is, we can have a pizza class as the base class with a function getDescription and cost, and then we can add the properties for the extra toppings. Has cheese, has jalapeno, has olives. And this base class will again be extended by the Margherita pizza, Veggie Paradise, and the Farmhouse pizza subclasses. And we will use these properties to calculate the final cost of the pizza. Now let's say if the cost of any of the toppings changes. So we need to open up our base class and make the changes to it. Also, if a new topping is introduced, we will again have to change the base class, which clearly violates the open-close principle. The open-close principle says that the classes can be opened for extension but not for modification. So this doesn't work as well. So what we are going to do is use the decorator pattern. One object will have the reference to another and delegate it some work. So now let's redesign our pizza application. Taking one example, let's say the Margherita pizza. So this will be our base object. Let's say you want to add a topping for extra cheese. So what we will do is create another object for extra cheese and wrap it around the Margherita object. So extra cheese here will be our decorator and will have a cost of its own. Also, the extra cheese is of type pizza. Same applies to another additional topping, let's say jalapeno. So we create another object for the jalapeno and wrap it around the extra cheese object. So again, jalapeno is another decorator for us. The margarita's cost is $2.99. Extra cheese costs us 40 rupees and jalapeno costs us 20 rupees. So we call the function on the outermost object, which is the cost method, and it delegates our call to the cost method of the extra cheese object, which again delegates the function cost of the margarita class. Now the base class or the innermost class will return its cost to the extra cheese object. Now this extra cheese object will add up its own price with the margarita price, which is $2.99 plus 40. And again, the jalapeno's cost will be added to it. So the last decorator in the stack would be the object that the client actually works with. So this way we can add as many decorators as we want to our pizza and extend its functionality dynamically. Now looking at the class diagram for the decorator pattern, there are two important parts. The first is the component, which declares the common interface for the wrappers and the wrapped objects. Now this component interface has a function, function1. Now concrete components is a class of objects that will be wrapped. It defines the basic behavior which we can change or add additional behavior to using the decorators. In our case, the margarita pizza. Now the concrete component implements the component interface and hence overrides the function, function1. The third is the base decorator. Now this base decorator has a field for referencing a wrapped object, and this wrapped object will be of the type component. And this is so that the base decorator can contain both the concrete component as well as the concrete decorators. So this base decorator uses the reference of the wrapped object to call this function1. Now speaking of the concrete decorators, this defines the behaviors that can be added to our components dynamically. In our case, those were the toppings, which was again of the type pizza. This concrete decorators override the methods of the base decorator, which is function1 in our case, and also add extra behavior to the object either before or after calling the parent method. Now comes the client. Now this client can wrap the component with multiple layers of decorators only if it works with the component interface. And this is because the concrete component and the base decorator have implemented the component. As discussed, we will first define the subscriber or our observer. I'll call my subscriber interface as subscriber. So here is our subscriber interface. Here we have an update method and it accepts a parameter post ID. So currently we are working on the demo application in which we notify all our subscribers about any new post that we publish in our blog. And here this post ID is the ID of the post that is being published. Now we need to define our publisher class. I'll call it Healthy Me. Here we will create a field that will have the list of subscribers that can be stored comprehensively. We will define another field called post, the change in state of which will trigger the event in this Healthy Me publisher. Now I'll write the method to add the subscribers into our subscribing list. And here it is. Register subscriber. It accepts a parameter which is an instance of our observer or the subscriber. Here we add it to our subscribers array and I have echoed a statement subscriber added. Now we'll write the method to notify the subscriber about the change in the publisher. And I'll call it notify subscribers. Let this function be empty for now. Now I'll define the business logic which will trigger the event in this publisher class. Let the function be publish post. Now here we define the business logic. It can be as complicated as you want, holding important codes as well. Now we will keep the things simple here. Now on publishing this post, our field variable post will be updated and assigned as the post that we have passed in our publish post method. And from here, we will call the notify subscribers method. Now, in the notify subscribers method, we will loop through each subscribers, and I'm using the for each loop to do that. And now for each subscriber, we will call the update method. And into it, we will pass the post that is being published. So our publisher class is now ready. You can add the remove subscriber method of your own. So here, our subscriber interface, the publisher class. Now we need to define our concrete subscriber. Say one of the subscribers list for us are the ones who want the update on the food blogs. So we will call the subscribers list as food update subscribers, and it will implement the subscriber interface. And here it is. Now since this has implemented the subscriber interface, it will also implement the update method. And in this update method, we will just echo a statement, and our concrete subscriber is also ready. So here we have an interface, the publisher, and the concrete subscriber. Now you can define as many concrete subscriber as you want, and it has to implement the subscriber interface. I'll keep just a single subscriber for now. Now comes the time for the client code. In the client code, we first need to create an object for the publisher, another object for the subscriber. And here it is. This is my publisher object, and this is my subscriber object. Now after defining this, we need to register this subscriber into the subscribing list of the publisher. Publisher register subscriber and pass the instance of the subscriber into it. And now we will publish the post which will trigger an event. Let's say the post ID is 12. So we are ready with the client code as well. Now let us execute this code in our terminal. And here it is. It says subscriber added and the new post with ID 12 published. Thus, here the subscriber is registered and hence this statement is executed. Subscriber added. And after this, when the post is published, the publish post function is called and the subscribers are notified. So this was all about the observer pattern. An event occurred, which was the publishing of the post, and hence all the observers or the subscribers listened to the event and a notification was sent to them. So in a nutshell, the observer pattern is used when changes to state of one object requires changing other objects. Or so to say, an object observes other object and changes accordingly. So this was all about the observer pattern in PHP. Now summarizing the behavioral patterns that we learnt in this module. The behavioral patterns are for designing the communication algorithm between the objects. Now these are concerned with assigning the responsibilities to the object. Strategy pattern is the behavioral pattern in which we encapsulate each algorithm and let a class use them interchangeably during runtime. Then is the observer pattern in which it lets an object subscribe to the state of another object to observe the change and update accordingly. So this was all about the behavioral pattern and the design pattern in PHP. For our courier application, we are going to use the factory method pattern. So this is my IDE. I'm using PHP Storm. We will start the other way round. We will start with the interface or the product and then proceed with the abstract class. So here is my interface, my transport interface, and this is the abstract class courier. Here this is my factory method, abstract function get courier transport, and it returns the transport interface. Now in the transport interface, we will define the behavior that our different type of transport is going to have. Ready, dispatch, and deliver. You can find all the code in the helper file 1 of this module. So we are ready with our product, which is the transport interface for us. Now we will create our concrete product, which will be our plane transport and the truck transport. So these are our two concrete products. The plane transport implementing the transport interface and same with the truck transport. Now we will override the methods. And here I have implemented the method from the transport interface. Now we need to define the behavior for each of our product, that is the plane transport and the truck transport. To keep things simple, I'll just add the echo statements for each of the functions in our concrete product. And here it is. You can find all these codes in the helper file 1 of this module. For the plane transport, in the ready function, the courier is ready to be sent to the plane. Courier is on your way on the plane. And for the deliver function, courier from the plane is delivered to you. So we have defined the behavior for our plane transport. And similarly for the truck transport, the ready function, dispatch function, and the deliver function. So we are ready with the product part of our factory method pattern. Now moving to our abstract class. Here we have defined the factory method, and this will allow us to change the type of transport objects created by the subclasses of this courier class. Now let us write the business logic for this class. We will write it in a function sendCourier. We will call the function getCourierTransport, which will return us the transport object here. Now this transport object can be the plane transport or the truck transport, depending on the subclass. And now we perform the business operation on this transport object. So we are ready with our abstract class courier. And our concrete class for the factory method pattern is now ready. Now we need to define the subclasses, which will be our concrete creators and will return the concrete products. So starting with the air courier, this air courier subclass extends our courier class. And here we have the function getCourierTransport, which is our factory method. And this will return us the object plane transport, which is our concrete product. So here we have successfully changed the type of object which is created. Similarly, for the ground courier, and here it is. The ground courier extends the courier class. Here is the factory method, and this creates another object type which is the truck transport. So we have separated our code for creation of the object and the code for the business logic. The air courier supports the transport by plane and the ground courier class supports the transport by truck. So we are ready with the design of our application. All we need to do now is create the client code which the user will directly interact with. Now since this is an example code, I'm writing everything down in a single file. So here is our client code. the function deliver courier, which we will call to deliver a courier. Now this method deals with all the internal code and business logic. All we need to do to start a courier delivery is to call the deliver courier method. Now let me write the comment for each of the classes and the functions to make things easier for you. And here it is. So here our code is ready and our application design is all done. All we need to do is call this client function and pass the instance of our concrete class. So for example here, we are creating a test courier and we are calling the deliver courier function into which we are passing an instance of the ground courier. Let us run our code and see what happens. And here it is. This is the test courier. And now since we are passing the instance of the ground courier, the object of type truck transport is created. And accordingly, we have the output. The courier is ready to be sent to the truck, the dispatch function, and then the deliver function. Courier from the truck is delivered to you. Let us try for the air courier now. We'll just copy it and pass the instance of the air courier type. Running the file again. And here it is. This is the code from the ground courier. And here we have the code from the air courier. So that was factory method pattern. So cases in which we could go for the factory pattern. We can use the factory method pattern when we do not know the type of object we might have to create or work on. Right now, we had two types of object to work on. In future, we might have many more. So in such cases, we could use the factory method. Now the factory method pattern separates the object creation code or the product construction code from the code which uses the product. So anytime you want to add a new product, you can just extend it without having to change anything else. So this is how factory method pattern makes our designing easy.